Hey guys, today we'll be going over chapter 7, which is on learning, and I just want y'all to be aware that this is the chapter that has the most missed test questions on the second exam. So this is definitely a chapter that you want to spend some time reading, digesting, understanding, because this chapter will be probably the most difficult to answer questions about. So let's go ahead and get started and hopefully clear up any confusion along the way. So learning is all about acquiring through experience new and enduring information or behaviors. So coming upon something and introducing it into kind of your memory and your experience. So there's two types of learning that we talk about in this chapter. The first is associative learning, and that is learning about two things that occur together. Now, next to associative learning, I want you to write something down. This is the first trap of this video. I want you to write down the word conditioning. Next to associative learning, write down conditioning. And we'll talk about two different types of conditioning in this chapter. The first is classical conditioning, and the second is operant conditioning. But both types of conditioning are known as associative learning methods. Whereas cognitive learning is all about observational learning. So write down observational learning next to cognitive learning. So like I said, this chapter is broken into three parts. Those three parts are classical conditioning, operant conditioning, and observational learning. So associative learning is that classical and operant conditioning, and then cognitive learning is that observational learning that we'll talk about. So then with cognitive learning, that is just by observing or watching others or through language, and that's how you learn your information, by taking in all these experiences that you see others doing and learning from them. Whereas associative is more personal. These are things that you experience happening close together and you start to associate them. It's kind of like when you've been through enough storms, you know that right after thunder comes lightning. That's associative learning. I know that these things occur together. If I hear thunder, then at some point I'm going to see lightning. Or if I see lightning, then at some point I'm going to hear thunder, right? And then a stimulus is anything that evokes a response. Respondent behavior is the response to that stimulus. So you can think of the stimulus as the cause and then the respondent behavior as the effect, right? So if the stimulus is hot weather, then my respondent behavior is going to be to sweat. This is an automatic response. It's not something that I tell myself to do, but it's something that happens in response to the stimulus of hot weather. So stimulus is cause, respondent is effect, respondent behavior. And then operant behavior is behavior that responds to the environment. And so anytime we talk about operant conditioning or operant behavior, it'll really be in the context of like parenting or reward and punishment type stuff. So, if you don't make your bed, your mom won't give you your allowance, right? That's operant behavior, is to know that there's a consequence if I don't do something. So I'm going to do the correct behavior of making my bed because I want the good reward of getting the allowance money, right? So respondent behavior happens automatically. That has to do with classical conditioning. Whereas operant behavior is something you do by choice to avoid a punishment or to gain a reward. Either, let's say your mom will spank you if you don't make your bed, so you make your bed to avoid the punishment of getting spanked, or your mom will give you an allowance if you do make the bed, so you do the behavior of making the bed in order to get the reward of the allowance. So respondent behavior is an automatic response. Operant behavior is a choice based on wanting to avoid a punishment or get a reward. Okay. Now, classical conditioning, you may have heard of this before, and the most frequent example or study that students usually know about is Pavlov's dogs. So this was when Ivan Pavlov, who was a researcher, noticed that every single time he opened his dog's food, the dog would start to salivate before he ever even gave him the food, right? So he started to do this thing where every single time he gave the dog food, he first rang a bell. And then at some point, the dog would actually start salivating right as soon as it heard the bell, whether or not food was present, because it began to associate the ringing of the bell with, oh, food is coming, right? So working off of that example, let's talk about, all of these: unconditioned stimulus, unconditioned response, neutral stimulus, conditioned response. So like I said, classical conditioning is a type of learning where we link two or more stimuli together. And so the first stimulus, which in this example would be the bell ringing, comes to elicit behavior, the dog salivating, and anticipation of the second stimulus, which is the presentation of food for the dog. So an unconditioned stimulus is a stimulus that unconditionally, which means naturally or automatically, triggers an unconditioned response. And the unconditioned response is an unlearned, naturally occurring response, which is usually something biological, to an unconditioned stimulus. So let's pause there. In this example, the unconditioned stimulus would be food. It means that it's a stimulus that unconditionally, naturally, and automatically triggers a response. So anytime in the presence of food, a dog will salivate. That's just an unconditioned response. It's something you don't have to teach the dog to do. It's just something that it does. And that's true with humans too. If we smell food, our salivary glands do start to produce more saliva just because we're smelling the food. And that's really just evolutionarily adaptive to help you swallow food down easier when you start to eat. So the unconditioned stimulus is something you don't have to teach yourself to respond to. So another example, like I said, could be hot weather. And then the unconditioned response, I don't choose to have this response, but I automatically do, is sweating. Unconditioned stimulus, food. Unconditioned response, salivation. Unconditioned stimulus, someone embarrasses you. Unconditioned response, you blush, right? So unconditioned stimulus is something that is going to trigger a biological, natural, unlearned response in you every single time. So, like I said, the unconditioned response is usually biological, like nausea, salivation, anxiety, those sorts of things. Naturally occurring biological responses that do not have to be taught to someone. So when you see test questions that give you an example of classical conditioning and then ask you, to identify the unconditioned stimulus or unconditioned response, know that for the unconditioned response, you're looking for an automatic reaction, not something that someone chose to do, but something that their body just does in response to a stimulus. And then a neutral stimulus is a stimulus that before you condition it elicits no response. So in this example, the bell at first would be a neutral stimulus. When you ring a bell, a dog shouldn't just salivate for no reason. But if every single time you ring a bell, you then feed a dog food right after, soon it will begin to associate the bell with the presence of food coming after it. And so that bell will then trigger the dog to salivate. And it's at that moment when it realizes, oh, every time that bell rings, I'm going to get food. And it starts salivating at the sound of the bell, that the bell turns from a neutral stimulus into a conditioned stimulus. After association with the unconditioned stimulus, food, it elicits a conditioned response. And so when you're going through these examples, sometimes people are looking for like 5 separate things: US, UR, NS, CS, and CR. But the neutral stimulus and the conditioned stimulus are the same thing. The only difference is that before you conditioned it, the neutral stimulus, the bell, caused no response. It didn't cause salivation in the dog. And after you conditioned it, after you repeatedly paired it with that unconditioned stimulus of food, it did cause a response. Now the bell is causing the dog to salivate, which is what makes it now a conditioned stimulus. And then by that same respect, the unconditioned response and the conditioned response are also the same thing. The difference is that they're responding to different stimuli, but they are the same biological response. So the conditioned response is still salivation from the dog, but it's salivation when it hears the conditioned stimulus, the bell, rather than salivation that occurs when it hears or experiences the unconditioned stimulus, which is the food. So again, we present food to the dog, which makes it salivate. That is unconditioned because it happens naturally. You do not have to train, you do not have to condition the dog to do this thing. So the unconditioned stimulus, I present the dog with food. The unconditioned response, the dog salivates. Well, now every single time I present that unconditioned stimulus of food, I ring a bell. And at first, the dog's not going to salivate when you ring the bell, which makes it a neutral stimulus. It's eliciting no response out of the dog. But the more times that I ring the bell and then give the dog food, the dog learns, right? Learns that the bell means food. So now it starts to salivate whenever it hears the bell. Now the bell is a conditioned stimulus. And the conditioned response is salivation still, but salivation to the bell, not salivation to the presence of food. Okay? I know it can be a little confusing, but hopefully I've broken that down enough for it to be a little more understandable. Okay. And so acquisition is the point at which the dog or the participant, whatever experiment you're running, realizes that the neutral stimulus, the bell, signals the unconditioned stimulus, food. So its acquisition is really the moment when a neutral stimulus turns into a conditioned stimulus. So I've rang the bell, I've given the dog food. I've rang the bell, I've given the dog food. I've rang the bell, I've given the dog food. Now I've rang the bell and the dog gets all excited and starts salivating because it knows that food is coming. Aha, that is acquisition. The neutral stimulus, the bell, which was causing no salivation, has turned into the conditioned stimulus. Now when you ring the bell, you get a conditioned response of salivation from the dog. So acquisition is the moment that the dog realizes that the bell signals food. Extinction is the loss of that understanding. And so let's say, I've rang the bell and given the dog food tons of times. Now every single time I ring the bell, the dog starts salivating because it knows it's going to get food. Well, let's say that now I stop giving it food. I just ring the bell whenever I please, and I don't give the dog food ever. Well, at some point, the dog is going to unlearn, right, that association. It's going to unlearn that association. And it's going to say, oh, well, now when the bell rings, I don't get food, so it doesn't matter anymore. I'm not going to get excited and get ready for food if it's not going to happen, right? And so it starts to unpair the bell with the idea that food is coming. So the conditioned stimulus of the bell turns back into a neutral stimulus. So that is extinction, is the opposite of acquisition. We stop pairing that conditioned stimulus with the unconditioned stimulus, and so the dog unlearns the response to salivate to the sound of the bell. And then higher order conditioning is really just a second step in the process. So let's say the dog has already learned that every time you ring the bell, it gets food. Well, now, every time that we're about to ring the bell and then give the dog food, we turn on a purple light. So we turn on a purple light, then we ring the bell, then we give the dog food. Turn on a purple light, ring the bell, give the dog food. Purple light, bell, food. Purple light, bell, food. Do it, over and over until the dog realizes that every single time that purple light comes on, they're going to hear the sound of the bell, and then they're going to get food. And so now the dog will start salivating to just seeing the purple light turn on. So that is higher order conditioning, where we just add one more thing before the first conditioned stimulus. So we kind of have a second conditioned stimulus. And you can, continue to do this 3 steps, 4 steps, 5 steps, right? Kind of however many you want. But higher order conditioning is now just linking together a chain of events instead of just one before the unconditioned stimulus. Spontaneous recovery is this idea that once you've extinguished a conditioned response, so you go through extinction, the dog unlearns that the bell signals food, but sometimes just randomly, if you kind of wait long enough for the dog to sort of forget about unlearning the association, I guess. Sometimes if you ring the bell, the dog will suddenly just start to salivate. even though the bell no longer signals food. And so that is spontaneous recovery. It's just the dog hears a bell and starts getting excited and salivating again, even though it's been a long time since that bell signaled food. Okay, now generalization is this idea that once you've conditioned a response, ringing a bell equals food, the dog may actually respond to similar stimuli as the conditioned stimulus. And so let's say that the owner of the dog has a doorbell, and the doorbell doesn't sound exactly the same as the bell that he rings before he gives the dog food. But let's say that the dog has generalized and thought, oh, any bell that I hear is going to equal food. And it's that idea of any bell rather than just the one bell that means food. If it starts responding to any bell, that's generalization. So the doorbell rings, the dog starts salivating and thinking it's going to get food. That is generalization. So you would teach discrimination in response to that. So every time the doorbell rings, the dog doesn't get food. It has to learn that only when you ring that one specific bell that you have does that mean food. So discrimination is being able to tell the difference between the one stimulus, the bell, that will elicit the unconditioned stimulus, the food, and any other stimulus that is similar, like the doorbell. So generalization is not understanding that difference between the one stimulus that will give you what you want and other similar stimuli that won't. And discrimination is understanding that difference. Okay. So preparedness is this idea that we are biologically predisposed to learn certain associations, such as between taste and nausea, particularly associations that have survival value. So here's a good example that I'm sure everybody has experienced. If you have ever eaten something that gave you food poisoning, I bet that you never wanted to eat that thing ever again, or at least it took you a while to become comfortable with the idea of eating it ever again. So you start to associate that food with feeling sick, right? And this doesn't take, over and over and over. You don't have to, let's say, eat oysters 5 or 6 or 7 times and become nauseous every single time in order to sort of learn that aversion to oysters and to be nervous to eat them again. Sometimes it only takes once. And that is the idea of preparedness, that sometimes it only takes once. And those times where it only takes once to learn an association are times where that association has survival value. So because it makes you sick, which harms your health and is not helpful in surviving, it's something that you don't have to experience over and over and over again to get the message that you shouldn't keep eating that thing, right? Right, so this is what I just explained. If you became ill after eating oysters, you'd probably have a hard time eating them again. The smell and taste would have become a conditioned stimulus for nausea. So let's, go through US and CS and all that stuff in this example. So the unconditioned stimulus would be whatever bacteria is in the food that made you sick. The unconditioned response is nausea in response to having bacteria in your system. Again, these are unlearned. They are unconditioned. You don't have to teach yourself that bacteria should make you nauseous. That's something that just naturally happens in your body, right? But, the smell and taste of specifically eating oysters, even though every oyster isn't contaminated with bacteria that'll make you sick, the smell and taste of oysters become the conditioned stimulus. You associate the smell and taste of oysters with having gotten sick from bacteria, right? So that becomes your conditioned stimulus, and your conditioned response is the same thing as the unconditioned response, nausea. But nausea in response to the smell and taste of oysters, instead of nausea in response to bacteria being in your system. And the smell and taste of oysters would have been a neutral stimulus before you got sick, but once you got sick, it became a conditioned stimulus. Some applications of Pavlov's work. Drug cravings. When addicts are around people that they used to do drugs with, or they're in places where they used to do drugs, they're more likely to feel a craving for the drug use because they associate those people and those places with the use of drugs. So that's why, after rehabilitation treatments, we never want to have people go back to those same situations that they were using in, because it's hard to overcome that learned association, that trigger for wanting to use again. Food cravings. We associate unhealthy foods with an enjoyable sensation of their taste, which is why it's so hard to turn down a second serving of something unhealthy after we've already had one. And then immune responses. This is really interesting. When a taste goes along with a drug that influences immune response, the taste alone can produce an immune response. So let's say you were given a medication that was minty, right? And that medication made you feel better. It boosted your immune system. Well, the next time you taste something minty, your immune system can actually have a response to just the taste of mintiness, which again kind of speaks to that placebo effect, mind over matter part of psychology, where things don't necessarily have to be real for your body to have a very real response to them. My cat just picked up something and dropped it on the floor, if you heard that. Okay, so that all was classical conditioning, the first third of this chapter. Now we're moving into operant conditioning, which what I said is very much like parenting or reward and punishment. So operant conditioning is a type of learning where behavior becomes more likely to happen again if you reinforce it, or less likely to happen if you punish it. And reinforce is really just kind of another word for reward. If you reward a behavior, it's likely that that person will do the behavior again. But if you punish a behavior, it's likely that person will not do the behavior again. And the law of effect really just states this very simple rule. So behaviors that are followed by favorable consequences, behaviors that are followed by rewards, become more likely. It's more likely the person will do that behavior again. And behaviors followed by an unfavorable consequence, a punishment, become less likely to occur again, right? Because if you're rewarded for something, you want to do it more, so you can keep getting the rewards. But if you're punished for something, you don't want to do it more because you've been punished for it. It's pretty straightforward, simple logic, but the law of effect is what we call that understanding. An operant chamber, or Skinner box, is a chamber that has a bar or key that an animal can manipulate to get some kind of reward, usually food or water, some kind of treat. And attached devices are going to record the animal's rate of bar pressing or key pecking. We use bar pressing for animals like monkeys and key pecking for animals like pigeons, for example. So this is used for teaching animals operant conditioning. So if every time a monkey presses a bar, you drop a treat out of a slot for it, well, now it's going to learn, I better press that bar all the time because I want these treats, or these bananas, or whatever, right? Okay, so like I said, reinforcement is like rewards. Reinforcement is any event that strengthens or increases the behavior that it rewards, that it reinforces. Whereas punishment is any event that weakens or decreases the behavior that it's punishing. And so the goal of reinforcement is to get a behavior to continue. The goal of punishment is to get a behavior to stop. And so next to these, I want you to write down, next to reinforcement is for good behavior, and the goal is to keep the behavior happening. Reinforcement is for good behavior, the goal is to keep the behavior happening. And then next to punishment, write down, punishment is for bad behavior, the goal is to get the behavior to stop. Punishment is for bad behavior. The goal is to get the behavior to stop. Okay. And then shaping is where you are trying to get a specific behavior to happen from an animal, from a child. And so as that child or animal gets closer and closer to the behavior you want them to do, you reward them along the way. And there is something that we call successive approximations. I want you to write that down here. Successive approximations. SUCCESSIVE, successive. Approximations, APPROXIMATIONS. Approximations, successive approximations. And successive approximations is, write this down, rewarding tiny steps towards the ultimate goal behavior. Rewarding tiny steps towards the ultimate goal behavior. So, for example, if I'm trying to get a poodle to learn how to balance on top of a ball, I would reward the poodle for doing any behavior that comes even close to what I'm trying to get it to do. So if the poodle just walks up to the ball, wow, great job, poodle. I'm going to give you a treat for that, right? And so that's the first successive approximation. That's the first step towards the behavior I want it to do. Now, I'm not going to reward it anymore until it does something even closer to what I want it to do. So now it has to actually, let's say, touch the ball with at least one paw. Once it touches the ball with at least one paw, great job, here's another treat. Now, I'm not going to reward that again. I have to wait till it gets even closer, till it makes another successive approximation towards the goal of getting it to balance on top of the ball. So now I want it to put 2 paws up on the ball, and I reward that. Next, I want it to actually, physically try to jump up on the ball, reward it for that. Next, I want it to fully stand on the ball and balance, and then I reward it for that. So successive approximations, just rewarding tiny steps towards the ultimate goal behavior. A primary reinforcer is a stimulus that is innately reinforcing. You don't have to teach it to be reinforcing. So a great example of that is food. You don't have to teach people that they should want food. That's just biological. It satisfies a biological need. Another primary reinforcer might be sleep, right? That satisfies a biological need. You don't have to teach someone that they should want to sleep. But a conditioned reinforcer is a stimulus that gains its reinforcing power through its association with a primary reinforcer. So this is a secondary reinforcer. Yes, so this is something that you sort of teach someone to be reinforced by. So, like earning a good grade, for example. There's no reason that, earning a grade should really be all that important to you biologically, but you learn that that is what your parents expect of you, and you get some kind of reward for getting a high grade. And so you teach someone to sort of want to strive for that high grade, even though the grade in and of itself is not really all that rewarding. You learn that it is rewarding based on the responses of others. Okay. So operant conditioning, we have these exact same terms of acquisition and extinction. And so acquisition is the moment that you realize that your behavior leads to a consequence, whether that consequence is a reward or a punishment. So let's say, let's use making your bed as an example. If you make your bed, then you get an allowance. If you don't make your bed, you get spanked, right? So as soon as you learn that making my bed leads to either a reward or a punishment, now you have acquisition. You understand that your behavior leads to a consequence. But let's say that, your mom has stopped giving you allowance for making your bed, and she stopped spanking you for not making your bed. So now you sort of get rid of that association. You no longer associate making your bed or not making your bed with a reward or a punishment. So it's undoing the acquisition, just like in classical conditioning. Spontaneous recovery is, again, the reappearance of an extinguished response. So, you've been making your bed every single day, and then your mom stopped rewarding or punishing you for it, so you stopped making your bed. But then one day, you just wake up, and out of habit, you make your bed, even though you're no longer being rewarded or punished for doing so or not doing so. That's spontaneous recovery. Just spontaneously, you recovered the association, and so you did the behavior. generalization and discrimination are, again, much like in classical conditioning. I think this is funny. So let's use this example. So like I said, every time you make your bed, your mom gives you an allowance. And so you go over to your friend's house to spend the night. And when you get up in the morning, you make your bed, and then you walk up to their parents and you say, "Where's my money for making my bed?" That's generalization. You think that no matter where you are, if you make your bed or the bed that you're staying in, you're going to get money for it. That's generalization, because you don't understand that it's only when you're at your house and with your mom that you actually get that response or get that reward of money, right? So discrimination is understanding that difference, that, oh, it's only when I'm at home in my own house, in my own bed with my own mother, that I'm going to get money for making the bed that I've slept in. So generalization, thinking it's going to happen in any situation. If I make any bed in the whole world, I'm going to get a reward for it. Versus discrimination, oh, it's only if I make my bed, this specific bed, that I get a reward. Okay. Reinforcement schedules. This is the first type of test question that people most frequently miss on this exam. So a reinforcement schedule is a pattern of how often a response is reinforced. You can either partially reinforce something or continuously reinforce something. So continuous reinforcement is you get a reward or reinforcement every single time you do the desired behavior. So every single time you make your bed, you get money for it. Whereas partial reinforcement is you don't reinforce the behavior every single time someone does it, just some of the time. So let's say instead of every single day that you make your bed, you get money for it. It's that if you made your bed every day for a week, then you get money at the end of the week. So we only reinforce the behavior after it's happened a certain number of times or after a certain length of time, as opposed to continuous reinforcement. You are rewarded every single time you do the behavior. So when it comes to partial reinforcement, you get a slower acquisition. It's slower for you to understand that association of when I do this behavior, I get this reward, but it's much greater, or it's much more resistant to extinction than continuous reinforcement, because you understand that it's not every single time that you do the behavior you get a reward, but you know that if you keep doing the behavior long enough, you're going to eventually get a reward. So then, actually, before we move on to these, here in G question 2, I want you to write down some words at the top here before you write anything next to this: fixed ratio, fixed interval, variable interval. So I want you to write the word fixed, and next to that either an arrow or an equal sign, whatever. Fixed means predictable and consistent. Fixed equals predictable and consistent, meaning that you know when your behavior will be reinforced. You're aware, you know when your behavior will be reinforced. Fixed equals predictable and consistent. You know when the behavior will be reinforced. Variable is the opposite. It's unpredictable and inconsistent, random. You don't know when it will be reinforced. So write that down. Variable equals unpredictable, inconsistent, random. You don't know when the behavior will be reinforced. Ratio equals number of times your behavior is reinforced after you do the action a certain number of times. Ratio is number of times. Whereas interval is an amount of time. You get a reinforcement after a certain amount of time that you've done a behavior. So again, fixed, predictable, consistent. You know when your behavior will be reinforced. Variable is unpredictable, inconsistent, random. You don't know when your behavior will be reinforced. Ratio is that your behavior is reinforced after a number of times, a specified number of times of you doing the behavior. And interval is that your behavior is reinforced after a specific amount of time has passed since you've done the behavior. Okay, now moving on to combining these. Fixed ratio schedule. This is a reinforcement schedule that reinforces a response after a specific number of times that you have done the behavior. So an example would be a buy 10, get 1 free deal. It's fixed because you know how many times you have to do the behavior. I know I have to buy 10, frozen yogurts or something to get 1 free. And it's a ratio. I have to buy a certain number of yogurts, 10, to get that reinforcement of 1 free. Fixed, I know what I have to do. Ratio, I have to do it a certain number of times. And I know what that number of times is because it's fixed. It doesn't change. Variable ratio is a reinforcement schedule that reinforces a response after an unpredictable number of times. So this would be like slot machines. I have no idea how many times I have to play the slot machine, but eventually, if I keep playing it, I've got to win the jackpot at some point, right? So this is not a variable interval because you can't just pull the slot machine and then sit there for a certain amount of time and not pull it again and just expect that you'll win the jackpot just by sitting there for a certain length of time, right? You still have to play the slot machine a certain number of times in order to win the jackpot. But the difference is you don't know how many times you have to do it. And the number of times changes between every win. So that's what makes it variable. You don't know how many times you have to do it, and the number of times that it takes to win the slot machine changes every single time. Fixed interval. So you know how long it's going to take to get a reward. So this example would be you get an allowance every week for doing your chores, or you get a paycheck every week for doing your job. I know that it's going to take exactly 1 week, an amount of time, interval. I know, fixed, that it's going to take an amount of time, interval, to get the reward that I want if I keep doing the correct behavior of doing my chores or going to work. And then variable interval, you have no idea how long it's going to take, but after a certain amount of time, your behavior will be reinforced. So checking your phone for messages, for example. You have no idea how long it's going to take to get a message, but eventually at some point, someone will text you, right? But it's at an unpredictable amount of time. I have no idea how long it's going to take. The amount of time that passes between getting a message and getting another message is unpredictable. It changes. Okay. Now let's talk about positive and negative punishment and reinforcement. So these are examples of operant conditioning. And so what you need to know is that punishment, like we talked about before, is anything that decreases the behavior that it follows. Because punishment, like we said, is for bad behavior. We want the behavior to stop. Whereas reinforcement is for good behavior. We want the behavior to continue. Now, understand that positive and negative, as we use it in terms of operant conditioning, does not mean good and bad. Positive does not mean good, negative does not mean bad. I want you to think about it as sort of like a mathematical type thing, where positive just means that something is added or given, whether that thing is good or bad. What determines goodness or badness is whether you're using reinforcement, which is for good behaviors, or punishment, which is for bad behaviors. But if it's positive, then you are adding or giving something. And then if it's negative, you are subtracting or taking something away. So this will make more sense in context. But there are 4 combinations of these that you can have. You can have positive reinforcement and positive punishment, and you can have negative reinforcement and negative punishment, which is what makes this now the second most missed test question. So those 4 are going to be your answer choices: positive punishment, positive reinforcement, negative punishment, negative reinforcement. And given an example, you have to decide what any given circumstance is or displays. So positive punishment is when you give or add something bad so that you can stop a behavior. Positive, I'm giving something bad because I want to stop, punish, decrease the behavior. Negative punishment, you are taking away something good to stop the behavior. Negative, taking away something good because we are punishing. We want to stop the behavior. Positive reinforcement, you're giving or adding something good to get the behavior to continue. Positive, giving or adding something. Reinforcement, getting the good behavior to continue. Negative reinforcement, taking away something bad, again, to keep the behavior continuing. Negative, taking it away. Reinforcement, to increase the behavior because it is a good thing. So let's use some examples. That'll make a lot more sense. So positive punishment would be like giving a spanking, right? This is a bad thing. The child is not going to continue to do the bad behavior because it's getting a punishment, right? Giving a spanking. Positive part is that you're adding or you're giving something. The punishment part is that it's bad because you want the behavior to stop. Negative punishment would be like taking away TV watching or gaming privileges. Negative because you are taking something away, particularly something good, because you want to punish the behavior. You want the behavior to stop. Positive reinforcement would be like giving an allowance if the child does their chores. So you're giving something good because you want the behavior to repeat, to continue, right? And then negative reinforcement is sort of the weirdest one that we see the fewest examples of, but here are two examples that are pretty good ones. So, you know when you're in your car and you don't put on your seatbelt, that's a bad behavior, not putting on your seatbelt. We don't want to reward that. But when you do put on your seatbelt, that annoying beep, beep, beep sound goes away because you've done the good behavior of putting on your seatbelt. So taking away that annoying beeping sound that the car makes once you've succeeded in putting your seatbelt on. That's a good behavior that we want to reinforce. The person is likely to repeat that behavior of putting their seatbelt on because they want to avoid that negative stimulus of the annoying beep. Another example would be an alarm clock. So there's an annoying alarm sound, and when you do the correct behavior of turning off the alarm and getting out of bed, we take away that annoying sound to reinforce the good behavior of getting up out of bed and turning the alarm off. Okay, last section here. So a cognitive map is really just a mental map. That's how you can think of it. Really just a mental map. So we usually use this in terms of like mouse studies or rat studies. So after running a maze, rats act as if they've learned a cognitive map of the maze. So once they have run a maze enough times, they no longer have to stop and try every single turn to figure out where to go. They just run from start to finish because they have learned a mental or cognitive map of the environment that they've been exposed to. This is also like, think about the layout of Baylor campus, or think about the layout of your apartment, for example. And if you can see that layout in your mind, it's because you've made a cognitive map of it. Latent learning is learning that has occurred, but it is not obvious until there's an incentive to demonstrate it. So, for example, if you just put a rat in a maze and it learns the maze, it has no good reason to just keep running the maze from start to finish correctly, back and forth. I'm going to run the maze perfectly without making any mistakes just because. That really doesn't make any sense. Why would a rat do that, right? But if you put a block of cheese at the end of the maze and it understands that by getting to the end of the maze, it's going to get the reward of having the cheese, well, now it's going to run the maze perfectly. It doesn't want to make mistakes. Why would it? It's going to get to a reward. And so when you put an incentive down, then the rat actually demonstrates the learning that has occurred. They have learned a cognitive map of the maze, but they're not going to show you that until you give them a reason to. You give them an incentive, food. Intrinsic motivation is a desire to perform a behavior for its own sake, right? So just because you want to do it, you like to do it, it brings you joy to do it, all for its own sake. Whereas extrinsic motivation is a desire to perform a behavior because it's going to give you a reward or help you to avoid a punishment. So doing something because it will get you a reward. Let's say that your parents pay you $20 for every A that you get in your classes. You're not intrinsically motivated to get A's. You don't care about your grades, but you do care about money, right? So you're motivated by something outside of the immediate experience of doing well in your classes. Whereas someone who's intrinsically motivated would say, I just get so much satisfaction out of getting an A in a class, or I just love school. I just love to do the work. I love learning, right? That's intrinsic motivation. I'm doing what I'm doing for its own sake because I enjoy to do it. Whereas extrinsic motivation is, I'm doing it because it's going to get me something good in the end that I really want. And then, like we talked about, observational learning is learning by observing other people. And so modeling is this idea that you are observing and imitating a specific behavior. And so this is really kind of the best way to get children to do good behaviors that you want them to do, is just by doing them yourself, modeling those behaviors for them. So if every single time you get into the car, the first thing that you do is put on your seatbelt, you model that good behavior of putting on your seatbelt, then children are going to observe and imitate that same behavior. Oh, every single time mom gets in the car, she puts on a seatbelt, I should do the same thing. I'm going to copy her, right? And that's kind of what observational learning comes down to, is just copying other people. And then mirror neurons are special neurons that exist in your frontal lobe. And some scientists believe that they fire when we perform certain actions or observe other people performing those actions. And so what I want you to write down next to mirror neurons is, mirror neurons are for copycat behavior. Mirror neurons are for copycat behavior. One great example that we all experience is if you see someone else yawn and then you yawn, it's because your mirror neurons are firing. You might not realize it, but we actually copy other people's behavior really frequently. The next time that you're sitting across from someone, just try crossing your legs and see how long it takes for the person in front of you to also cross their legs. Or change your body position and see how long it takes for them to copy that body position. These are pro-social behaviors, behaviors that are helpful or that enable you to have connection with other people. We don't realize it most of the time. Our mirror neurons firing are unconscious, but we really do imitate and copy other people frequently because it helps us to fit in, which is really the goal of pro-social behaviors, to fit in. Right. Okay, so that is all for that chapter. Do make sure that you submit your pre-session worksheet to Canvas before the Zoom session. Go ahead and do it right now. And I will see you at the session at 8 p.m.